about. So, welcome to the working group device management on May 14th. Remember, this is under the Kubernetes Code of Conduct, so please be kind to each other. We unfortunately don't have John Villameric with us today. Unforeseen circumstances made it impossible for him to participate. So I'll be your host today, and I've slightly rearranged the agenda. John planned to talk a bit more about the concrete use cases. I'd like to use the opportunity to perhaps take a little step back and think about what we are doing with a prototype right now. And I started taking some of the ideas that John proposed and played with and discussed with you guys, and I try to map them back to what we currently have with the DRA API. The goal is kind of to meet in the middle. That has always been the intention, but John starts from scratch, designs the ideal API from the ground up with use case-based evidence and usability in mind. And I kind of move towards that from what I know will work from an implementation perspective. And this is something that really just started end of last week or so, and it started in earnest on Monday and today, with Kevin Hughes from NVIDIA also being involved. The idea is that we take ideas from the prototype, the best of both worlds in a sense. I don't know whether it's successful, that remains to be seen. What we are currently doing is we go through all the YAML example files that John had in his prototype about known use cases, and we are rewriting them using new API types or API types that are a bit more closer to the current Kubernetes API. All of that is on a critical path, so we can deliberate and discuss use cases all day long, but finally we have a release timeline for Kubernetes 1.31. I think it was announced last week or so. So we now know that the cap freeze will be on June 14th, followed by code freeze less than a week later, less than a month. That was a Freudian slip, I think. Actually, can you still hear me? I don't see much from anyone.
I hear you.
Yeah, good.
Yes.
Just continue. If that all sounds okay with you guys, then I could jump over to a PR that I just created today, just basically the last half hour, and show you a comparison, a side-by-side comparison of concepts in DRA 130 from 130, John's prototype, and this new potential alternative. Does that sound like something that we should dive in now? It's still fairly high level. I'm not going to talk about individual types, just ideas and concepts.
Yeah, that sounds good.
Okay. Then I switch over to my other browser tab. So there is now a PR pending. The important part is that I created a new directory alongside the existing RM prototype, and you basically can do a diff between files in those two directories. The README is the same, the directory structure is the same. What is new is here this comparison table, and I think that I'll start there, explaining how it differs. Actually, my rationale is missing, so I need to make that a bit smaller. I hope you can now see all columns, including the rationale at the end. So I'll just dive in from the top to bottom, and you can shout, ask questions whenever something doesn't make sense. I know that Tim only has half an hour, so perhaps we'll go through the half an hour if we can, and we can continue later on if necessary. Let's talk about classes. That's perhaps the biggest conceptual difference between the two prototypes. In DRA 130, the class was required. You had to have a driver name there. So in a sense, the resource class was specific to a certain DRA driver. The prototype continues with that, but it also specializes with the class a bit further. It's now about one particular device in a way, with one particular vendor providing that hardware. Then there's a mechanism for vendor-independent classes that select other classes through some labeling mechanism. So there is a mechanism to get vendor-independent resource allocation, but it's a two-step process. First, you need to select the right class, and then within that class, you select device instances. And what I'm proposing is to have a more generic resource class, which is functionally more or less at the same level as a resource claim. You can do everything that you can do in a resource claim, including asking for multiple different devices, all with settings in a resource class. And there is no concept of selecting a resource class by label. That is all handled at the device attribute level. So device attributes can now be vendor specific, with the shorthand notion that you are familiar with just a short word, a DNS subdomain. That is basically within the namespace of the driver, but we can also have standardized labels, say, for example, under the KSIO namespace, and those labels, those attribute names then can have a standardized meaning. And you can mix and match those in a filter expression in Cell. So you can ask for something with vendor independent attributes, and you get every device that claims to be a GPU according to some Kubernetes definition, for example. And it's all using the same mechanism. So that's one difference. The resource classes are now also optional. So users don't have to select a resource class. If they are happy with specifying everything in their own resource claim, they can. What they don't get is the more privileged configuration options. Those are still limited to resource classes and therefore to admins. So that concept is still present, but it's an opt-in. And basically, resource classes are like inheritance. You create a claim, you inherit some attributes and some defaults from the resource class if you want to. And what you inherit is defined by the admin. So that's perhaps the one conceptual difference.
Can I ask a question? Sorry, I don't have a hand button
Yeah.
on this new console. One of the questions that we haven't really answered well is how we're doing access control. Like in, I think either of the prototypes really. We've sort of hand waved that we would do quota on class usage or something like that. If class is now optional, how do you do access control?
I do have one section further down on quota or resource. Well, somewhere is a line about that. I suggest that we do actually do a resource quota object in our API group. The existing V1 resource quota, although it uses the name resource, but it's actually about API resources. It limits how many of those you can create. And you might use it with stretching the definition a little bit to things that have certain field sets, but this is really stretching it, and it's not meant to be used for that, and extending it is hard. So I think we should do a quota mechanism. Initially, we will use it for management mode. I think that's where it shows up in this current proposal. But we can also extend it, say, with a cell expression. A cell expression that iterates over allocated devices in a namespace, sums up some attribute values like amount of GPU memory used in a namespace or allocated in a namespace, and compares that against a threshold. And then we can get quota limitations that are actually based on our device model and how we describe resources, which is simply not possible at the admission time that the existing V1 resource quota is based on. This can also include, and I do have it in my comments for the proposal, this can include an allow list and a deny list for classes. So you can say in this namespace, you're not allowed to use this particular class because it would give you access to configuration options that you are not supposed to have in this namespace. It's part of a design. It's not immediately something that I would implement for, say, 131, but we could try. And Kevin, I think, had his hand up. I didn't explain something well enough. He has something to add. Please go.
No, yeah, no, it wasn't, that you weren't explaining it well. I think you were. I just wanted to step back a little bit and kind of give a higher level overview of what you're going through here. So Patrick has this table that he's put together, which, you know, as he pointed out, it kind of compares what John's K8s ARM prototype, how it compares to an evolution of what currently exists in 130 today to adapt those to um, similar features that John's prototype has, but in a way that is a very clear evolution from the existing DRA APIs rather than a complete rewrite and a complete rethinking of what they look like. And so, you know, what he's going through here in these rows is just kind of a comparison of all the different high-level abstract concepts that have been debated over the last few months in relation to this. And then me and Patrick sat down today and started taking the APIs that he's put together and evolved and actually writing out the YAML for all these. So John had a bunch of YAML that he wrote against his prototype abstractions. And now we're taking those exact same YAML files and modifying them using the API that Patrick's kind of evolved and proposes here. And I think he said the same thing a minute ago, but I just wanted to also put it in my own words because I don't know, as you were describing it, even though I know exactly what you're talking about, something was missing in the description there. And so I just wanted to reiterate it in my own words real quick.
Thanks. That hopefully makes it clearer. The list of the table is not necessarily prioritized. I think classes are indeed the biggest conceptual difference. The others is a collection of things that I basically ran into as I compared the types. I can just continue, or you call out questions, things that you care about in particular, and I jump to those. But I'll just continue and see how it goes. So the custom CRD approach API, I think that is something that was very prominent in DRA 130. It's a lot less visible and can be ignored completely in the new proposal. We now have resource claim as before, but the spec is basically the inline parameters or the parameters that were previously in a separate type, and now they are inline. So to the user who doesn't use vendor CRDs, it looks like he's just creating a normal type. But the CRD mechanism is still there for the claims, for the claim specification, because that is potentially hard to write for users. And that's where we may want the ability for a vendor to really put in everything that a user normally would write, including list of requests of devices that need to go together, match criteria, all of the complicated stuff that can go into a resource claim could come from a different vendor CRD, but it doesn't have to. I think that's the whole point. We have debated some other alternatives. I think John's proposal currently relies on just pulling configuration fragments from vendor CRDs, but that has, yeah, it's more limited. A vendor can't create, for example, the list of requests. They can't specify what devices to allocate. That has to be defined by the user or by a class. And it also means that core Kubernetes components now need to read CRDs. Even if it's just for pass-through, that may be an issue during implementation review. We would need to check that. With the proposal here, we just do it the same way essentially as in DRA 130, except that it's less visible. But you will see that in the YAML files where you most of the time won't even see that a CRD might be involved. Then management access. I think we talked a little bit about that already when Tim asked about quota. So the concept here in the two proposals is very similar. There is a Boolean that says this device request here is for management access, which has the implication that the claim gets access to the device, but doesn't actually occupy it or doesn't take it away from other pods. So the same resource instance can still be used for other claims. And this monitoring pod or management pod just gets kind of like a less intrusive access to it. because it can monitor things that are in use in a different namespace. This is a privileged operation, so we need to have some permission checking in place. And the proposal is to do it as a quota system that is specific to resource claims, where we can say in the quota spec file, management access is allowed in this namespace. And this would be checked at allocation time. That's where we have all the parameters that are needed to make a decision. We know also how much has been allocated, so we can extend this with device-specific attributes that say limit, I think I managed the GPU memory allocation limit per namespace already. This is something that can be implemented at allocation time because whoever does the allocation knows about these things and can do or can evaluate a cell expression that sums up something. John, in one of his comments, pointed out that the current mechanism that he had for management access basically only worked for management access in the resource claim, and that really was because he was basing it on the admission time check. Then moving on, pod level claims, how pods reference claims. That is a flat list in DRA. It was a little bit confusing to me how John planned to do it. He didn't have a fully specified pod spec type yet. And I think it was going back and forth a little bit. So what I'm now proposing is basically the same as in 130, with the additional shorthand from John's proposal about give me a claim that uses this class. If we agree that this is something that is very common, it's almost not a conceptual change at all. It just needs some code to be written to make that templating mechanism work. And it would behave the same as manually create a template, resource claim template with that class in it. So it's not difficult. Then that's again a point where there has been some back and forth. We now basically need at some point in the next row, actually, we need to talk about this matching between different devices and which devices actually get matched during allocation. So let's talk about the match attributes first. Match attributes is basically a specification that you are allocating multiple devices at the same time, and you need to have them share some common attributes, or there are some other limitations that like they must be on the same PCI root. John introduced match attributes for that as a special case. It's not a general solution, but I think it is indeed the best one that we can come up with at this point. The question really is, where do we put the match attributes? I think we both have it at the claim level. In a claim, you can ask for multiple devices, and you can say all of these devices must match on certain attributes. I think it's the same proposal ultimately, but it does have implications for the container asking for access to a specific device. If at the pod level, we only have one claim asking for multiple devices, it might make sense to say, okay, my container A needs device A and container B needs device B. So what I've added is basically an alternative to the existing claims field or list where a container gets access to all devices in a claim. And the alternative is to be more specific and say, in this claim here, I want access to a named device or to the result of one request in that claim. And that is typically another specific device.
So, sorry, if I can just pause there for a second. So does that mean if I really wanted to, I could organize all of the devices I want injected into my pod into a single claim rather than multiple claims, and then pick and choose them out using this new mechanism? Even if I didn't want to align across something.
And the limitation obviously is that if we really have to align between different claims, say, for example, you have a pod that uses an existing claim that has been set up beforehand, say perhaps a network device or something that is easily accessible from multiple nodes. And now you want to allocate new devices for that port that are somehow close to that other claim. We currently don't have a solution. We would need to put match attributes into the port spec for that. But given that these match attributes themselves are, in my mind, just a short-term solution until we have a more general mechanism, doing that in the V1 port spec is probably premature. And we are not ready for that yet. I think this needs a bit more thought. We can experiment with the match attributes in the claim, get most use cases covered that way, and then branch out or expand once we are confident with this approach. Okay.
For
So
what
this
it's
is-
worth, I think you're right. I talked to John about that too. I told him I suspected that the 2-level model would be necessary, and if we can punt on the cross-claim coordination till later, I think we'll have more understanding later of the problem.
Yeah.
So
Yeah,
good.
I see it being I see it being less common than wanting to allocate them together. Yeah.
So the next thing is alternative device sets. So the main use case that keeps coming up is give me a device of type X. If I can't get that, give me Y and Z instead, but never both. So it's kind of like a special case with potential different solutions in an ordered priority list. With DRA 130, you could do that in a custom controller with classic DRA, but not with structured parameters. John put in one-off and all-off. I don't think we need all-off, but I kept the one-off. It's one of those things that is a special case, but if we all agree that it's common enough to have some special handling for it, in particular when we don't have a general solution yet for the overall problem, then it may be worthwhile doing. So this is all part of my proposal. Kevin?
So I'm happy to leave one of out of the scope for right now, if we leave room for something there.
That's what I was about to say. So there is a way to do all of with what he already has. It's just implied.
Yeah.
Rather than having all of things.
Yeah, well, from an API point of view is where we get to the fun part, where one of is actually one of the elements of a one of, where the elements of the one of are all of or one of. Now parse that out, AI. But if we leave room for it in the API, then I'm happy to leave it out of the scope for right now.
I agree. I'm not sure whether I put it into the comments, but I started annotating some of my types with this is stuff for 131. This is potentially later extension. I'm not sure whether I've done it for the one-off, but I agree. But it is part of a struct where we can say, okay, we need different alternatives, and one-off is a potential extension for the future. The common case would be an outer list of requests. That's where the all-of comes from. All of these requests are meant to be satisfied, and each entry is typically a single device. And it could be a one-off in the future. Okay. Moving
So
on.
you said it could be a one of in the future. You mean an all of in the future?
Well, no, I think we don't need the all-of, because the all-of is the outer list. That's already part of the resource claim spec in a sense that it lists multiple requests, at least in my proposal. I think John didn't have that. He had one struct that was a single device, all of, one of, and I changed that to an outer list, which is basically the all of containing individual devices or a one-off.
Yeah, I think John has some modeling of sort of hierarchical shared attributes. And so the outer part was sort of like, if you want to share a bunch of attributes across devices, but I think you're right. I have to go back and look at what you've written specifically. Yeah. I think you're right that we can use it for the same thing.
Yeah.
For the all of.
And that's the outer request list is also where you put in the name that you potentially and optionally request or reference in the container. So that's perhaps worth pointing out that we do have requests inside the resource claim with a name, which is optional because you don't always need it. But if you need it, you can put it there and reference it elsewhere.
So I apologize, I have to drop off. I'll catch up with you later on your notes and your PR and do what I can to review it. I'm in a meeting all morning today, but this afternoon I'll get to you.
We'll probably not have it fully finalized for you to review today because I think we need to go through the exercise of actually doing all the general updates and see whether we missed anything. Some of the type definitions are a bit tricky, like the one-offs and a naming of general fields. So we need to make sure that it looks nice. I hope it does.
Okay.
But we're not
I'll
done
ping you
with
on
that.
Slack.
Yeah.
I'll ping you on Slack later. If it's useful, I can do it from an API review perspective and say like what's going to fly best and what won't before you write a ton of YAML against it and then end up having to re-indent everything.
Yeah, if you want
If
to.
it's useful, I'll talk to you later.
I don't know. I don't know yet. We really
Okay.
need. We've done what we have converted so far is the classes,
Okay.
validating the class concept in a sense because I wrote down the concept and Kevin did the YAML update. So I think he now understands what I was aiming for. We still need to do the same for the pods and claims. The pods are probably simple, but the claim, that's where it gets interesting, what it really looks like with nesting of one-offs that I
Ping us
still
later.
have. Yeah.
Ping us
Okay.
later, we'll tell you where we're at, and then we can take it from there.
Yeah.
Sounds great. Thanks, guys.
Okay.
But-
What about the rest of the audience? Shall we just keep discussing it? I think it
Does
would
anyone
be
have,
useful.
does anyone have
Yeah.
questions? Does anyone have questions before we move on, maybe? Otherwise, just keep going, I guess, yeah.
Everyone has fallen asleep. Yeah, I'm sorry. I'm not as charismatic
Patrick,
as
one
Yeah.
question.
Sure.
Is partial allocation supported somehow?
Yes.
I don't see like any
Okay.
option.
What we have is optional. What I have is optional allocation. So for request, you can say I want typically one device. I also have a mechanism to specify a range, like give me 0 to n devices, where 0 is explicitly allowed. And if you don't have one available on a node, you're just not getting it and you have to do without. That's the optional allocation that we had in the original DRA. The minimum of 1 and no maximum would be useful for the management mode. You basically get access to all devices on the node, but that's not what you were asking. You were asking for partial allocation of a more complex device. It's not in this proposal yet. It's still using the same named resources from 130. Simply because I want to nail down the higher level API first before we dive into the fairly hairy and red hole dangerous area of modeling more complex hardware. But Kevin did some work on adding partitioning to the named resources model. And I think our plan is that once we know that this alternative prototyping actually goes somewhere, that we'll bring back that approach and add it to the proposal. So
It's actually
we
in
might,
that, it's in that third folder that's
Yeah,
at the top level of this project. If you go in there and run through the README that's there, you can see how the partitionable, at least MIG devices for GPUs is what I've used as the example of how you would use the new mechanism there.
Okay.
One difference between 130 and the current proposal is that previously I was very strict about talking about models and you could do requests within a certain model. I think I've dropped most of that. So it's now talking about allocating devices, and devices could be described with the named resource model, but it could also be more complex with slightly different behavior, but same query language, same filter, same user API, just a different way for a Kubelet plugin to publish its resources. As long as it's in a format that is understood, we still need to define that. But the filtering by attributes, for example, that could be the same for both ways of publishing resources from a node. Yeah. Any other questions? No, then yeah, let's talk about the tough one. Scoring is actually, yeah, I'm a bit surprised that this hasn't come up yet in the use case discussions, because when you describe constraints, like give me one GPU, this is the simplest, or give me one GPU from a certain vendor. That is a very simple constraint that can easily be satisfied on different hosts with different kinds of GPUs, but which one should the scheduler really pick for a pod or a claim? And we don't have a mechanism to tell the scheduler that. In classic DRA, it could have been done with the controller pod, where the vendor knows what's best, or the user can specify in the CRD that he wants the smallest GPU that fits, or the biggest that's available. We just don't have it in any of the current proposals. I envision that eventually we will have something like the matching mechanism with a cell expression that gives a numeric range based on what is being allocated. But it is currently in none of the proposals, and therefore it won't be in 131. Maciek, yeah?
I have two questions here. So first of all, I've seen John present kind of concept of one-off. Wouldn't that involve scoring? My understanding was in one-off there were multiple options that was to be treated as a list of preferences.
Yeah. So the one-off is a kind of special case of where the user explicitly gives some priorities. But the simple case is give me one GPU, and I'm not sure how to fit that into a one-off, where the first say, well, they could say one-off, big GPU, middle GPU, slightly smaller GPU, smallest GPU, all in a one-off, and then the scheduler would iterate through those and try to satisfy the first request first. But that's kind of an iffy API, to be honest. We would prefer something that says, give me one GPU, and I want memory to be as large as possible, or as small as possible, but larger than this minimum threshold that I need for my application.
Okay, I see. And the other comment I've been making a few times already is the scores are respected by scheduler, but are completely ignored by both Cluster Autoscaler and I believe Carpenter. I know Carpenter team is on this call, so they could speak about that as well. And I don't really think we have any plan or specific idea how to include them. So the downside of doing scores as they work in scheduler is basically your preferences only matter if you already happen to have all the possible options in your cluster, but otherwise they get ignored. This is already the case, I think, with things like preferred node affinities, just as an example. And so if we're not targeting 131 in particular, I think it would be worth to invest some time to think if we can express preferences in a way that could be also supported by Autoscaler. I think that's the main challenge, at least the way I see it, and I think other people may have different opinions, but the way I see it is basically score is specified on the level of a single pod. However, Autoscaler adds nodes in order to support multiple pods at the same time. So that would need to be somehow expressed in a way where the preference could be combined and like somehow reasoned about if I have multiple different pending pods. And so this is kind of goes beyond just how scores work in scheduler.
Yeah, I agree. This is a big problem. So a lot more thought needs to go into that area.
I agree. It's very challenging. I don't have any good answers. I just wanted to kind of raise it as a topic for discussion.
So perhaps right what we're doing right now and ignoring it in 131 is indeed the only thing that we can do, as long as we know that we have some place in the API where we could put a scoring mechanism. And I think we do. It's kind of at the same level as the matching. So I'm not worried about extending the API later. It's really just a question of what should we put there and how would it work? Okay. If there are no other questions, I'll keep going. The claim status in current DRA is only where the scheduler or the controller store the allocation, and the reserved for information is managed in the status. John looked at some use cases from the networking team or network folks and correctly identified that we also may need the per plugin status fields, where in a standardized format defined by some cap, not necessarily, certainly not the DRA cap itself, but for example, a networking cap could define an IP address field. That is, I think, the example from the prototype, where the claim status has an IP address, and that information comes from the kubelet plugin after it has prepared the claim. I'm not currently including that as an example, but it probably would just be the same hand wavy. We can put a field here thing that John has. Technically, it's problematic on multiple levels. All of the options that we have for getting that information from a plugin to the cluster have challenges. It's probably it's not worth going into those details right now, but we do have either versioning problems between kubelet being from some old Kubernetes release and the driver needing some newer version, but we don't want to update kubelet all the time when we do cluster updates. We could do it so that the plugin itself gets to talk to the API server, but then it needs permission to write into the claim status, which does have security implications. So this needs further debate about how to implement that. We don't need that right now in 131 because we don't have a standardized field for those different device types. What we're discussing right now is basically just consuming a claim. It's not publishing anything back yet, but we'll need to think about that. Then some other small difference, design choice, where one option may be better or worse, but the other also it's just subjective. Claim templates, they were a separate type in DRA 130. They are again or still in the current proposal. John decided to reuse the claim object and add metadata about labels and annotations in the pod spec to avoid another top level type. I think both Kevin and I find that confusing, and I think John wasn't entirely happy. So we've kept the separate type with a rationale that if people do a kubectl get resource claims, they actually want to see claims that are supposed to be allocated. And having something that's just a placeholder to be served or that serves as the input for templating would be confusing at that level. Okay, that's another difference perhaps that I might put up nearer to the top. Resource versus device naming. Obviously, the original DRA was all about resources without actually specifying what the resource is. John took the opposite approach, said we are managing devices, so everything that we define is a device request, a device claim, a device class. I'm not going that far in this compromise proposal. I'm keeping resource at the top level because that is a common API that isn't necessarily about what we currently consider a device. But inside, many fields are now named device where it makes sense. So I'm thinking of a resource claim as something that asks for resources like devices. And if it asks for devices, here's how. The long-term thinking is that if we need to add support for other things, then it's easier to extend the resource claim with an alternative in a one-off struct it's easier to do than adding another top-level API that needs to have its own API group and duplicates a lot of code that has already been written, but doesn't currently need to know about the details of allocation. There's a lot of common codes like creating claims from templates that's completely generic. It's not specific to devices. So this code could continue to work even if we add some alternative model for things that are not devices. Resource model, I think I already mentioned that it's less prominent now. I'm still keeping everything extensible. So if I'm not entirely sure whether some field is absolutely the right way to do, there is a one-off in Go struct that doesn't necessarily, or doesn't show up in the YAML structure, but under the hood, it means that we can add a new field in that structure, and components in the cluster that don't know about the new field will fail gracefully because they see an empty Go struct, and that tells them that they are missing some support that they should have. Then classic D-Array as a concept, that's the way how a vendor can control allocation of a claim. That wasn't part of John's proposal at all. In the new one, it is still there. It's not very prominent. You basically get back to the original model where a resource claim must reference a resource class, and that resource class must have a field that says, I'm being allocated by a control plane component provided by a vendor. Basically a driver name, except that it's not called a driver name anymore. It's a controller name. And if people don't care about that, they'll never see it, but the option still exists. And I think it's useful because a lot of the challenging things of the exploration that people have done with that controller concept will not be solved anytime soon with in-tree Kubernetes support. So we still need the ability for people to try out things while writing a controller. Next row, vendor configuration. So yeah, I think that's this level of what was this actually about? I think it's yeah, the concept of what is in a resource class, or in a class. In my case, it's a resource class, and it can have different vendor-specific parameters, both at claim and class level for different devices. If you don't know exactly which device you are getting, you basically need to be prepared. If you know that you can work with devices from two different vendors and both need to be set up differently, we need the ability to specify parameters. If I'm getting a device from a kubelet plugin of driver A, here's the config for that driver. If I'm getting something from driver B, here's the config for that driver. And that is covered. That is possible with this proposal. At the end of the day, what happens is that allocation looks at what device actually gets selected, what are the configuration pieces that have been specified in claim request at the claim level, in the class, and it puts that together for the driver in the kubelet to process those configuration options and apply them in the right priority. Do the validation that options are set as they should be. Yeah, that's part of the proposal. Then the partitioning, that's what Ed asked about. A single device that can be configured in different ways, where you get one configuration that then rules out doing other configurations because the resources of a device are basically occupied. This is an extension that's not in that particular directory, but it could be added if we merge in Kevin's proposal for partitioning. And last but not least, there's just really some minor details, but it is visible in the YAML files. That's why I put it in here at the end. As we were writing YAML files, we do have to write a cell expression in some places. And the syntax of that clearly has usability aspects to it. I think John was a bit liberal with making it very user-friendly. But it's not exactly how Kubernetes does handle cell. So if you really try to implement it according to Kubernetes guidelines using the Kubernetes infrastructure for cell, I'm coming to the conclusion that it has to be a bit different, more like what I had initially with strongly typed attributes where the cell expression already at compile time makes it known what needs to happen at runtime. That enables calculating a cost. That's a concept that we don't have. We don't have limits for costs right now, but core Kubernetes has it in other APIs where there is a certain complexity cost, basically, saying if you have a cell expression, it must terminate within a certain amount of operations. And that is checked at compile time when analyzing the cell expression. And that only works if it's known whether a certain expression is operating on a string, an integer. That's why I think we need strong typing. Sorry. Yeah, that's I'm sorry. That is the comparison. If you want to dive in, you could, but I really think you should wait a little bit. So the structure is the same as it was before under package API. We do have capacity types, claim types. Pod types is new. John didn't have that. Quota types is also new. It doesn't have much right now, but it shows ideas for the future of what could be added. Other things that you might not be familiar with is the test data directory. It now has a test. If you run go test in that directory, it will actually parse all the YAML files with strict validation to make sure that we didn't make a mistake in the YAML file and it doesn't actually match the code type. And it also does the cell validation. So it will walk through the different decoded objects, do kind of what the API server would do during validation. It will parse the cell expressions using the same code that I had in Kubernetes and make sure that there are no compile errors, no syntax errors in the cell expressions, which is admittedly very tricky. It's easily the most complex part of this whole thing, but I think it's unavoidable that we do have some cell selectors somewhere. Okay. Yeah, as I said, this is now a pull request. It's a pull request in the main repo. But we are still going through it. If you look at it right now, it's a good chance that we may have to change something while you're looking, so perhaps don't bother yet. But certainly by tomorrow, we should be confident enough to remove the work in progress. I hope, because we really are on a short timeline, and then get people involved to review it in detail and verify that use cases that haven't been captured yet, perhaps, work with this API.
And I just want to reiterate again that, John has his prototype. This is kind of an extension of existing DRA to provide similar abstractions and support the same use cases that John's prototype is trying to support. But by evolving the existing DRA API rather than completely replacing it. And so we're not sure which one is going to win out in the end. But we need to explore both avenues because, obviously iterating on what we have already is a bit easier. We have some confidence that what we've done so far works. And so iterating on that rather than completely replacing it with something new feels a bit more natural. But we're obviously taking a lot of the ideas that John has in his prototype and adapting them to be extensions of the existing model. And so I know it's probably confusing. Do I focus on John's model? Do I focus on the stuff that Patrick's presenting today? But I'm confident that in the next week or two, we should get to a place where these two things merge into one and we have an obvious path forward. It's just in a very high state of flux at the moment, unfortunately.
Do we want to maintain like examples for how different use cases are done with the? I mean, I'm imagining one more column here in this table, or you
Yeah.
think things are moving too much?
We
I
talked about
think-
putting a, go ahead, Patrick. Yeah.
We thought about doing jumbling examples in the table, but I think it gets too long. What you really can do is look at these test data files, and you can run a diff between the two directories. And because most of the
Well,
lines,
to be clear, you can't do that yet because we're not done yet.
yeah,
But-
you can for classes.
You can for classes, but what I mentioned at the beginning, and it probably wasn't framed in the right context at the time, but we're going one by one through all of the examples that John has under his directory in this repo, in this test data folder, and we're modifying them to use the abstractions that Patrick's talking about today. And so when he talks about diffing these two test data folders, it really will be a diff of, okay, this, if you look at the top here, there's something that, this must be in his test data folder. It says resource class with name example.com foozer, then it's got filter devices, driver name, and this is how you create a resource class to get access to a single GPU from the example.com-foozer driver. And John has this exact example in his, is just the syntax for his resource class, which he calls a device class, looks slightly different, but it has the exact same purpose and the exact same position in this file and so on.
Okay, yep, sounds good. I think once it's ready, we can diff and take a look. So folks will have an idea on what the UI looks like and if they have issues. with
Exactly.
it.
Yeah,
Yeah.
that's why we decided to do this. Patrick talked with Tim, I think, on Friday, and Tim suggested this be done mostly because, then you can have an apples to apples comparison, right?
Right.
John's been pushing this prototype forward in his own right, which is a completely valid thing to be doing, thinking, stepping back and rethinking how could we design this from scratch. But without this apples to apples comparison, it's really hard to wrap your head around, okay, what is the difference between the two models and how do we eventually move forward with one, the other, or some hybrid of them?
Yeah,
And I think-
you might have seen me commenting on the Slack channel about individual updates of a CAP. That was me thinking about how to move the current CAP forward towards this direction, but it never was a full proposal.
Mhm.
It was always incremental and it was never fully complete. So it would have been hard to compare, say, a CAP update that touches one part of the CAP against the full prototype. That's why we are now switching to the same rapid prototyping that John has been doing, where we present basically the whole structure as it will be eventually in a way that can be tested with Go test and YAML files. And then we validate that concept by getting people to review this new structure. And then we take it back into the CAP.
So I think one more question. Do we have any outstanding use cases that we have punted? Like if we select one model versus the other, like will we be in a situation where, oh, okay, this cannot be solved anymore? So should we be thinking about all the possible use cases and if roughly we can address them, if not all of them in 131, but the remaining?
I think that approach is still valid. I think it's definitely something that people should be doing. It's just hard to figure out whether we point them to one or the other model to express what they want to do. I think.
I would
Yeah, I
argue
guess
we
if,
need to-
right.
Yeah.
we need to
Yeah, I
put
guess
them
if
in
we have
one.
all the use cases, then we can just make sure that there's an example in each model to express that.
Yeah, I think John's been starting to, he's got his YAML files that he put together, which is a great start for us to be able to port things over to this now. But he's also in that Google Doc that was started after the first meeting. He started adding more text descriptions of the use cases,
Right.
where he says, okay, here's the bullet points of what I want to actually be able to achieve independent of what the YAML might look like. And I think the eventual goal would be to take each one of those and map those back to either a single file name or some object within this within these prototypes. So you can say, okay, this is covered, this exact use case is covered by this example back in the prototype.
Makes sense. Thanks.
Abhishek, I think you're next.
Yeah, thank you. Sorry, I joined a little bit late, but I guess a few moments back I saw a quota file somewhere, and I don't know if that exists in your repository. Did we review that, or?
No, it's
Yeah.
it's in my proposal. I clicked on wrong file.
So Patrick has a
Yeah.
PR opened against the working group device management repo that has these changes in it.
Yeah. So it is in my proposal. It's not in John's. And it's obviously not complete. So there's a long list at the bottom where I'm basically saying, okay, we can do these things in this quota spec or in this quota object in the future. And we would need to decide how much of that we pull in. It's part of the eventual release planning where we basically need to prioritize the things that we can do in 131 and start doing them. If we are quick, we can get more things done. But it all then eventually depends on how quickly we decide what to do and how much work it then actually is to implement some of these things.
Okay, I mean, just to probably, I mean, it's better if you can put I don't know, a very simple example of how you envision this quota specs in one of those examples, and that would align your thought process on how should we think about this. And
I don't know whether there is anything here for pot with management access.
No,
If
he
it's
hasn't put
not,
one.
yeah,
It doesn't
if it's
exist
not,
yet
we should
because
just add one, and then
we were
either
still
it's-
debating within John's prototype, we were still debating how it would be done. He has if you go to his README file, I think it's a one level up. Not that.
So yeah, he does.
Yeah,
He
so-
does have a list of open questions.
Yeah, the open
sub-questions
questions.
here.
But if you go to pull requests, and then he's got one specifically around the admin access, that second pull request.
Yeah.
So I think he probably doesn't have a prototype because he's still thinking through how he might do it.
okay, so if I were to understand, then quotas are only for admin access.
Right now, that's what I have in my document, but it could easily be extended. We just need to figure out how.
Mm-hmm. Okay.
Probably
I think
some cell expression. If you want to match or to define quota in terms of device attributes, it pretty much has to be. Yeah, well, it doesn't. Well, perhaps we can do the same thing as with match attributes, where we say sum up the quantity that is in this particular attribute, and do that without a cell expression. I haven't thought about it too much yet.
Yeah, I
But
think
this would be the place to put it, at least.
Yeah, I think the main point is something you said earlier and probably before Abhishek joined is that, this is a placeholder for us being able to eventually express quota against the type of devices that we are able to advertise using DRA. The existing quota mechanism doesn't cut it because it has no knowledge of resource slices, it has no knowledge of these complex devices that we're trying to make available. And so we need some new quota mechanism to enable that. Extending the existing quota mechanism isn't really going to fly because it wasn't designed for this. And so this is a placeholder where the first thing that we would use quota for is controlling management access to devices. But it could be extended, as Patrick said, maybe with an arbitrary cell expression to express things like, you're only allowed to have up to this much GPU memory, and you can do that using a cell expression that matches on the attributes you have available from your specific driver, and so on.
Mm-hmm. Okay, thank you. Is this written somewhere, or it's to be published, like Kevin, that you just described?
I think you need to dive. Well, I think I did have in that comparison table, I did have something about quota.
You had comments
Yeah,
within
yeah.
the Go
Yeah.
file.
The more specific now files change. So if you navigate to the content of a pull request, there is this API directory, and that does have a quota types file.
Okay, all right. Thank you. Thank you so much.
That's pretty much the level where we have been discussing details. We basically wrote down the structures and added documentation or comments, thoughts about these things, and that's what quota thing that I added.
Okay, thank you. I'll catch up.
I hope we have a recording. If it even hasn't stopped, we should be able to publish a recording. We are now at the end of the hour. So I think we can take a few more questions and then adjourn. Okay. Thanks, everyone.
Thanks,
I
Patrick.
hope it was useful.
Thanks.
See you again soon. And definitely we'll talk on Slack. So make sure that you follow what we're posting there. Thank you.
All right.
Bye.